Hello, everybody. I'm very proud to be there on PyCon Portugal because I already there since 2022, and every time in different places it's amazing and charming. And thank you for PyCon Portugal for possibility to see different states or cities of Portugal. It's amazing. Thank you. Okay, and today I want to tell you about complexity. Again, I already speak about complexity on different conferences, and this is next series of my talk about complexity. And today I want to speak with you how we can visualize it. And before I start, I cannot start. Why I cannot start? I don't know. Again. Okay. Before I start, I want to tell you who I am. My name is Maxim Danilov. I work many years with Python and Django, and I work also many years with JavaScript, reactive frontends. And also, I'm award-winning mentor in engineering. In a year, usually I work with around 150 persons. It means every second day, without any breaks, I help for newbie developers to go in Python development. And usually in my talks, I speak about usual things and how I can do and how I can achieve usual things in unusual ways. And this talk is exactly about it. Before I start to speak, I want to say thank you for my family who supported me on every my talk, on every conference. Thank you for my wife, Elena. Thank you for my children, Mark and Maya. Thank you for my animals, Marcel and Kisa. And special thanks also goes to my children. They provide all illustration for all my presentation on PyCon Science 2023. Okay, and let's go to topic of our talk, complexity. Small recap about theory. Complexity can be named in different forms. And of course, we have structural complexity. Structural complexity shows us or appears if we have big quantity of relations in big quantity of objects. Structural complexity reflects the structure of our project. The next is cognitive complexity. Who in own life says, I completely don't understand how it works. I say it every day. And it's especially about children-parent behavior. Cognitive complexity is strictly subjective measurements or metrics, because for me something is very complex, and for somebody others this is easy. And that's why cognitive complexity, this is subjective. The next complexity is accidental complexity. Accidental complexity happens always if we have the pressing of time. We should rush some compromises, and that's why accidental complexity appears in our code. And it is possible to reduce accidental complexity through refactoring, for example, but it happens. And at last, we have also essential complexity or technical complexity. If we implement the complex business task, we have technical complexity as is. We cannot reduce it. The only one possibility to avoid technical complexity, don't do anything. In this case, yeah, you can avoid it. Every project every project contains this all complexity. We have complex business tasks, we have a lack of documentation about our project, and we have time pressure. We should push and implement business feature. At start, this is not too complex and not too much developers we need to implement it all, but project grows. And project grows till a moment there appears the peaks of complexity. For example, if our complex business task was implemented and we have lack of documentation, in this moment, in special places of our code, appears complex places, which hard to understand how it works. After 3 days after implementing, the creator cannot answer how it works. Who meet this that? You write the code, after some weeks, you cannot understand how it works. Yeah, especially I works in alcohol, I works with wines, and for us it's allowed to drink wines at work. It's allowed, it's true, and the best parts of my code was written in drunken stage. Yeah, it's true, but I cannot answer how it works right now. And this is not a problem. Problem comes a little bit later if we start, if we skip to work with complexity in our code. Because the project grows and the complex parts start to clash together, and we have, and appears structural complexity grows because we create more compromises we have more compromises in our code. Also, accidental complexity grows because the time pressure works, and we should push more and more features in time. And also, cognitive complexity grows because lack of documentation grows. And this is not a problem. Problem, what appears in the middle? In the middle appears vortex of doom. And what it is, vortex of doom? In vortex of doom, we get the critical mass of tech debt exists in our code base. And at first, we should fix a bug. We fix the bug, and we get the new bug. And we should repeat it. And I show later example from this project, and probably I have seen this only one time in my life, but really to work with this project is a horror. And this project was frozen in last year. Okay, theory about complexity summary. Complexity at first is a subjective human measurement. The LLMs don't understand the complexity like humans. Complexity is not the same like a tech debt, but included tech debt in our code. Complexity is not a bug. If we don't have tech complexity, it means we don't do anything. But complexity leads to the bugs. We don't have any possibility to keep complexity on the low level. We can always write the easy code, but complexity slowly grows. And if we put the KPI which force us to measure complexity and simplify our projects like a KPI, we can achieve the better architecture. This is an important part, and we can see it later. Please don't forget to add in your part of work, working with complexity. Measure it, thinking how you can reduce it, and implement this code. And this is not refactoring, only refactoring. Okay, measuring complexity. The small, short steps. The first, count of code lines. This index you can hear anywhere. Or I have a project 3,100 lines. Or I have a project more than 3 million lines, for example, Dropbox, and so on. This index used everywhere. Who hear it? I have the project 10,000 lines. Yeah, I hope everybody. And this is measurement show us how big is our project. And this measurement is completely broken by black. I don't like formatter like black, rough, or prettier, because this is a stupid idea to split lists in area elements on the new line. This breaks paradigm of coding. And different statements on one line, Python allows it, and in some libraries I meet it. And usually, I write the more lines than enough, only to increase readability. It's, yeah, verbose is usually reduce the readability of code. In this case, reduce the cognitive complexity. Okay, counting of code lines example. I have the projects, it's around around 1,000 files. Total lines of code, we have around 300,000. But without black formatter, we have only around 20,000. Not around 20,000 or 30 or 40,000. Sorry, it stays there. Yeah, summary statements in code, lines of code, we have only 50,000. And max lines in file, 2,000 lines in file is complex file. And average, we have 52 lines in a file. It's a pretty good example. For example, Django frameworks has average 212 lines in a file, last version of Django. Okay, class function index. Class function index simply shows us in which paradigm this framework or this project's written. Object-oriented paradigm or function-based style. Also, we can find with this complexity measurement, we can find got objects or got functions. Got functions means this function 5,000 line, do anything, change all states in objects, and completely not testable. Yeah, who can test code? Yeah. Okay, pro and cons. Fast API written in style function composition. Function composition breaks this measurement, but okay, it works. And PyTest or unit tests should be excluded before you count this measurement. Okay, example. The big project, we have around 1,000 files, and you can see classes, we have around 2,000 classes, and we have around 3,000 functions. And in this case, I want to say for developers, boys, you work in function-oriented paradigm or in object-oriented paradigm. Okay, and average lines, code lines for function, it's around 10 lines. It's pretty well written for testing. Okay, dependency index. This is a next measurement. Coupling cohesion index. Who hear about it? Okay, other question. Who hear about coupling and cohesion? I hope everybody. And coupling cohesion index simply direct measurement of our structure complexity. If we can reduce it, it means we can reduce structure complexity in our project. But it's broken from Python itself, because if we use dynamic imports or if we import somehow on fly, this is pretty hard to measure dependencies which appears in runtime. Okay, next complexity metrics which I hope use every day, coverage. Who use code coverage? Yeah, amazing, yeah. 100% of code should be covered and not less. And code coverage, it's famous, but who use documentation coverage? Oh, thank you. The first hand in many talks, I see. Thank you. Documentation coverage, we have the perfect library, doc coverage, which help you to understand how you document your code. And I like the result for my project. Do you even use doc strings? No. Okay. Please don't forget about documentation coverage. I start to use it in my project, this library, because it helped me to decrease cognitive complexity in our project. Okay. Measuring complexity is pretty subjective. For example, we have Sonar Cloud. Sonar Cloud gives us measurement of cognitive complexity. I put in repository the report how Sonar Cloud invented these metrics. It's pretty subjective. Also, cyclomatic complexity, it's famous, but somebody used cyclomatic complexity measurement in your code. Who use it regularly? Okay. For measure cyclomatic complexity, the Radon, this is the best tool. And the clouds tools like CodeClimate or Codachi, they build it on the Radon. It's like simply web wrapper for Radon. Okay, touch depth metrics you can find in CodeClimate service. Composite code quality index you can find in Codachi. This is only subjective. This is only the numbers which can you use before some activity against complexity and after to compare it. And of course, every time is very, very subjective. Okay, complexity measurement summary. All metrics subjective. Before do anything, collect your metrics. After some complexity and changes, collect your metrics and don't forget to compare it. Okay, visualizing complexity. I can see dead people in my project. Okay, visualization theory. The best book which I read in last time is created in Switzerland and in Swiss. This book names Visualization Complexity. In the repository, I put the demo part of this book. This is amazing. They offer us a special structure how we can demonstrate complex things, and they offer like a steps what we should to do. I simply offer you simply to see it. No, not required to read it, but you should one time to see it. Okay, and for example, to visualize complexity in Sonar Cloud, they use numbers, and they offer us to understand cyclomatic complexity is not the same like a cognitive complexity. The next metrics is the next visualization is diagram. You can see I use the diagram to present how many code lines I have in file through whole code base. And you can see, for example, the commercial project, we have around 5 till 7 files with huge PI files with many code lines in files, and less files contains not more than 50 lines in a file. And for example, you can compare with open source library. This is probably Django, and you can see Django have pretty simply more files with long code lines. And usually, if you want to find something, you try to search exactly in file. There you have many lines. Okay, but this is all not interesting because how we can visualize structural complexity. The next example from depth-tree library, it's built on React. That's why if you have the very heavy project, be careful with creation of this visualization. But it's simply to use. You can create, this is example from my project. You can see I have some application with different colors, and you can see the volume of application. You can see internal cohesion. You can see external coupling. And you can also see decoupling ways. Because this is a stupid example, but the blue application which has color blue have only two coupling lines with other app. It means this is the first pretendant to be transformed in microservice, because it's simply not coupled with the rest of this project. Okay, the next tool I like especially, this is Nano API. This is visualizer which exactly right now visualize for us project with Vortex of Doom. It means we have some elements in project which can be removed like a microservices, but the big part cannot be changed without anything. Okay, and this is a simple way to visualize a structural complexity in projects. And the next visualization I like especially this is development process visualization. Who knows about it? This is my project, and you can see their Simply developer. You can see their tech lead, and you can see how the project grows. You can see the steps which happens in project development, and you can see the second part of this video. The project simply not changed. It's not frozen, but simply this project achieved the business goals. Finished. And it's performed business goals perfectly. What we have find in this video? In this video, we can find important moment. We can see stability, part of stability in development. We can see matured parts. We can see how modular is it, and we can see how complexity in project changed. Especially here, if you see this video, you can see this moment. Okay, in this moment, you can see the not one feature was added. The project was increased in twice. This is important moment. Exactly for this moment, the manager who works with complexity or developer, they should see how the accidental complexity increased. They should see how structural complexity increased. They can obtain the lack of documentation, and cognitive complexity changed. But technical complexity is stable. It's complex. And also, except enormous growth, they can also start reduce complexity in project, and you can see this element, this moment. Oh, this is amazing. And this part of our work, it's also accidental complexity grows again. What? I reduce the code base, but accidentally complexity grows. Why? Because not all elements ready to work in reduced part of my application. Also, structural complexity reduced, okay, and lack of documentation grows again. Why? Because we have many outdated documentation which should be rewritten. This is a problem. That's why refactoring, this is not a survivor. This cannot help us to reduce complexity, because refactoring is not all. We should also work with documentation and with structures. And cognitive complexity stays in the same stage, and technical complexity, our project is complex. Okay, the next step in development is areas of high developers activity. You can see this is name of files and how many commits I did in these files. And you can see on the last part of this diagram, files which contains accidental complexity, high accidental complexity. This is direct metrics to find there. Usually you can find the bugs. Okay, complexity visualization summary. All what you see and all what you want to interpret, it's subjective. Please, it's subjective. Visualization is only a trick to attract attention to problem, to see, to catch the problem, but it's obligatory. Visualization is a trick. It's only a trick how I can work with complex things. And please use different tools to find the best tools for you to visualize complexity. In this case, my talk is more oriented for tech leads or product owners who already should have their full visualization of this project. Okay, and refactoring, how we can refactor it all. I try to go through all faster. Smart refactoring. Smart refactoring. Okay. Michael Features says only few files changed often. Martin Fowler says some files should be clear for touch depth. And Pareto rule says 20% of files usually affect on changes in 20% of files usually affect on 80% of results. It means if you start to compile these three rules in one, we can find 0 touch depth zones. These files should be refactored. Any other files should be frozen. It means if you do refactoring like tech lead from a project which I showed previously, it's a stupid refactoring. Smart refactoring means you try to keep your energy only for in 0 touch depth zone. These files should be refactored. The next step, changing of abstraction level. This is important step, and you can see it everywhere. You start to work with functions. After that, functions goes transforms to complex function. After that, you start to implement classes. And Sandy Metz, this woman created the incredible article "Breaking the Behemoth." Links I provide in my talk in slides on the last slide. They say easy function is easier than complex function, but easy classes is easy than complex function, but more complicated than easy function. In this case, you can see the life of transformation of your code, and if you see the complexity, probably you can switch the paradigm from functions to classes, probably, not required. You can see you have function, And on the right side, you can see simply define the class. And if you don't want to break anything, simply initialize class in Lambda with the same name like function and don't break anything. And what I have else? Increasing modularity. About it, I speak on the last talk in Portugal. Who was on my last talk in Portugal? Yep. And there I speak about increasing modularity once more time. Casey Hightower, this is the first DevRel from Kubernetes. He says, organize your business logic as modular as possible, break it up across multiple repositories, keep components as a monolith, and get reduction of reduce complexity and simplify project. What I take this idea like a tech task, business task, and I have created the dependency extractor. And dependency extractor can help me extract only one function with all dependencies from project, from external libraries, and from built-in dependencies. And it works amazing till new tools appears. New tools, Nano API, they not simply visualize it, they also avoid to extract it and wrap it in Docker container. And right now it works like a charm. I don't know why I should support my library because yeah, Nano API do it better than me. Yeah. Okay. I-step async parsing. This collected multiple nodes, and after extracting, it can be worked, packed in a Docker container, and run it yeah, standalone. Okay, recap. Modularity required from us 0% refactoring. Extracted module can be run at standalone. We can reduce container image, faster download, test, deploy, and yeah. Extract can be performed from monolith exactly before creation of Docker image. It's amazing because my developers can work with monolith, and I extract only simple entry points before they run on production. Okay, manual imports control. How many times? No, nothing. Okay, sorry. In this case, I only want to say keys imports short. I want to say free dots deprecation. It should not be long import. And complexity hotspots. You have 73 imports. It seems like this, and it should not be in a file. Okay. I skip about type hints, and I only want to say documentation. Please write in documentation only unusual things, because any other things, famous things, can be added through LLMs. But you should write things which are unknown for LLMs. And this is always forgotten. I go to the new project, and I completely don't understand where I should get the security data, which ideas was implemented there, and so on. And LLMs cannot help me with that. Okay, recap. My words is about complexity, and working with complexity leads to better design of your application. Measuring complexity, important is because you should know the metrics. Visualizing complexity is only a trick to find the gaps or the points of problems. And if you're ready, if you collect all, smart refactoring can help you instead of big refactoring. And yeah, adding type hints is opportunity to increase complexity. I skip this information. And use tools like Nano API to isolate selected dependency. it works fast and furious. I like it. OK, try it yourself. Install Gurchi, clone locally any long-living GitHub Python project, and run in CLI and enjoy. It's amazing. OK. Obrigado, Cascais, and thank you for your attention. And right now, you can ask me. Okay, useful links you can also find in my slides. In this case, this all.